start with the topic of trigonometric equations, okay? Last objective. And we're gonna make it. So, to do that, or to solve equations, we have to first remember these four things. First off, what an equation actually is. So remember that an equation is a balance. When we have an equation, we have to have an equal sign, and what an equation means is that what you have on one side has to be exactly the exact same thing as you have on the other side, even though they might look different. But remember, an equation is a balance. So when we're talking about equations, we usually want to solve them. That is, when we started to put variables or letters in math, your favorite thing on earth, is when we started to develop the notion of solving equations. So we have a basic equation like this one. And when we talk about solving equations, it means that we have an incognita, like right here, and I want to find a value of x that satisfies this equation. What does that mean? Again, because an equation is a balance, it means that I have to find a value for x in such a way that what I have on the left side is exactly the exact same thing as on the right side. So this one is actually quite obvious, but I'm gonna do it by steps. So if I wanna solve for x, or in other words, solve the equation, what I always have to do is to leave my variable alone on one side. In this case, my variable is x, so I have to pass everything that is on my way to the other side. In this case, it's 2, so this equation ends up like 3 minus 2, that is just 1. So my solution is 1, x equals 1. What does that mean? Again, it means that this value for x satisfies the equation. What does that mean? That if I substitute x here, that is, if I change the value of x for the resulting solution that I got, it means that what I have on the left side is going to be the exact same thing as what I have on the right side. And this is obvious because 1 plus 2 is 3, and 3 equals 3. So that is a solution, okay, of an equation. So a more complicated example. Let's look at this. So a more complicated example, this is a 5, will look like this. I have to pass this to this side. Then my 5 is going to divide my entire equation, so my solution is minus 3. In this case, maybe it's not quite obvious. In this one, it was obvious that something plus 2 equals 3, then x had to be 1. So for this example, we can always solve it. And again, what does this mean? This means that if I plug the value of minus 3 right here, and I do the calculation for the left side, I'm going to obtain the exact same value as on the right side. So if I substitute minus 3 here, I'm going to have 5 times minus 3 plus 1, and what is that? Minus 15 plus 1, that is 14. And yes, minus 14 on the left side and minus 14 on the right side, okay? So that is a solution. We're gonna work with trigonometric equations, so you have to get the vibe of where we're going to. In all of these examples, what I have done, look at this, is I have isolated my variable on one side. So let's carry this into trigonometric functions. And you have worked with this type of functions already. So remember, inverse functions look like this. It's like a sine inverse, cosine inverse, tangent inverse, but you can also find them as arc sine, arc cos, arc tan, etc. Okay? And remember, inverse function, it means that undoes what the other one did. And you've been using them always to find, I think in at least 2 or 3 objectives, you've been using them to find angles. Why? Because I'm going to write a trigonometric equation, like this one. Sine of x equals 1. So I want to solve for this equation. This is actually the bonus tips points for those who can give me this answer straight away. What does this equation mean? It means sine of something is going to be 1. I'm going to give you a second to think about it. Sine of what gives me 1? Yes, the answer is pi halves, or 90. Okay, so let's do this again algebraically. What does this mean? Because for solving equations, I always have to leave the variable alone. I have to apply an inverse operation that undoes what the sign does. Remember, the x is not multiplying the sign. The x is inside the function a sign. Just as when we have quadratic equations, radical equations, my x is inside a radical. And for me to get rid of the square root, I have to apply the inverse function. In this case, the inverse function of a square root is raising to the power of 2. And if you recall, because an equation is a balance, if I do something on one side of the equation, I have to do it on the other side. What you know as pasar para el otro lado con la operación inversa. This is what it means. So, if I have a trigonometric equation, and I want to get rid of the outer function, and I want to get the, if I do this on this side, this is going to be my solution. Why? Because the function and its inverse cancel each other. So following that principle, I have to apply the inverse function to this equation on both sides, because this is an equation, it's a balance. And that way, on my left side, I can cancel the sine inverse with the sine function. So I have x equals the sine inverse of 1. And this is my solution. You will usually use calculators with this. So you can use, my favorite calculator is Google's one. So if I want to find the sine inverse of 1, I would just click, make sure your angle, your calculator is in radians, and then I would write inverse and select the sine inverse of what? Of 1, and that is 1.57, que es actually pi halves. Okay? So if you want to believe me, pi halves, let's do pi over 2, and that is the exact same value, okay? So x equals pi halves, or like the ugly calculator says, 1.57. Okay? The exact same solution we found at the beginning. So that is a principle of an equation. And what do we use? Inverse functions to undo what the trigonometric function does. Okay? We're going to elaborate on this topic further. This is not the level of complexity we will work, but I want to make sure we review the concept of inverse functions. Now, what happens if instead of me working with sine inverse of 1, I wrote here the square sine of x equals the square root of 2 over 2. Just let's think about this. Where does sine give me the value of square root of 2 over 2? If you think about it, sine equals y. And you know that there are two possible values for when sine equals the sine of something or an angle gives me square root of 2 over 2. And that is the pi fourths angle or the 3 pi fourths angle. Or in other words, there are two angles whose reference angle is pi fourths, and they give me the same solution. Okay, so I'm going to elaborate on this further. So we're going to be using a lot of reference angles. And also, we're going to be using a lot of remembering the signs of the trigonometric equations in the plane. Okay, so till here, I want to make sure we understood. Remember, sine of something is pi halves where? You can check your unit circle sketch if you don't remember. You filled up the entire unit circle or look for a unit circle in Google, and you're going to remember that sine of pi fourths, usen sus deditos, is square root of 2 over 2. And also, because sine is positive, here in this second quadrant, sine of the exact same reference angle, or 3 pi fourths, is also going to be the square root of 2 over 2. Why am I saying this? This is because this equation has actually two possible solutions. The one that's given by the reference angle by default, and the other one that is the other angle that has the exact same reference angle. In this case, 3 pi fourths, okay? This equation has two possible solutions. And if you think about it, there are a lot of values that can have two possible solutions. Just think about cosine of pi thirds is the exact same thing as cosine of minus pi thirds. Okay, so if I want to find an angle that in return gives me 1/2, these are two possible solutions: square root of 3 and minus pi thirds and minus pi thirds. Okay, so these are the two other concepts that we're going to use a lot to find solutions. Okay, so let's dive into the first really deep example.